children, let us continue the lesson time and motion. Okay, last class we have discussed about motion and about slow and fast motion. Also we have calculated the speed, isn't it? How we can calculate the speed of an object. Then what are the uses of odometer and speedometer? Listen it. And today's class we are going to discuss how we can calculate the speed. Okay, we can calculate the speed. You know, TGV, actually it is a train grande vitesse. Actually it is a French for high speed train. Okay, and TGV, actually it is a French word, train grande vitesse. Actually it is a French word for high speed train. So it is the world's fastest train. World's fastest train is actually TGV. Listen it. Then we can calculate the speed of the train. Listen it. We can calculate using a numerical. We can calculate the speed. Here we have a numerical. A train traveled 95 kilometer. A train traveled 95 kilometer in 10 minutes. Okay, a train traveled 95 kilometer in 10 minutes. What was its speed? We have to calculate the speed of the train. Listen it. We have to calculate the speed of the train. Here the distance, the train traveled a distance of 95 kilometer. Okay, in 10 minutes. What was its speed? Here we shall calculate the speed of the train per hour. Okay, we shall calculate the speed of the train per hour. Listen it. And here the question itself given the distance traveled by the train in 10 minutes. So we have to, in order to calculate the speed of the train per hour, we have to calculate the distance traveled by the train per hour. Then only we can calculate the speed of the train per hour. Listen it. So here the distance traveled in 10 minutes is given in your question as 95 kilometer. Okay, the distance traveled by the train in 10 minutes, actually it is 95 kilometer. Okay, next we have to find the distance traveled by the train per hour. You know, 1 hour contains how much minute actually? 1 hour contains 60 minutes. Okay, so we have to calculate the distance traveled in 60 minutes or 1 hour. Okay, so here we are using this relation for 10 minutes. In 10 minutes, the train traveled a distance of 95 kilometer. In 10 minutes, okay, in 10 minutes, train traveled a distance of 95. Then what is the distance traveled by the train in 60 minutes? So we have to multiply this into 60. Listen it. This is the distance traveled by the train in 60 minutes. Listen it. In 10 minutes, the train traveled a distance of 95. In 10 minutes, the train traveled a distance of 95 kilometer. Then what is the distance traveled by the train in 60 minutes? So we have to multiply by 60. Okay, and this 0 cancels and 95 into 6 actually it is 570 kilometer. Okay, actually this is the distance traveled by the train per hour, in an hour. Okay, the distance traveled by the train in an hour is actually 570 kilometer. 570 kilometer. So we can write the speed as 570 kilometer per hour. Okay, we can write the speed of the train as what? 570 kilometer per hour. Listen it. Next we can calculate the distance if speed is known. In the previous numerical actually we have calculated the speed of the train and distance is given. Listen it. Next actually we have to calculate what the distance. Actually the speed is given. Okay. If the speed is given, then we have to calculate the distance. Listen it. Then you know the relation. You can have the relation speed equal to what? Speed equal to distance by time. It's very important. Speed equal to distance divided by time. Okay. Speed equal to distance divided by time. From this, how we can write a distance? How we calculate if speed is known? The distance equal to, you can cross this. That is speed from this distance equal to what? The speed into time. So knowing the speed of an object, we can calculate distance. Okay, for example, we can consider another numerical. Okay, here if a Rajdhani Express train between Ahmedabad and Mumbai travels at a speed of 115 km per hour, then what distance will it cover in 4 hours? Listen to it, that is the question. Here a Rajdhani Express train, okay, that travels between Ahmedabad and Mumbai with a speed of what? 115 km per hour. Then we have to calculate within 4 hours how much distance that train travels. Okay, within 4 hours how much distance that train travels. That thing we have to find. Listen it here. If a Rajdhani Express train between Ahmedabad and Mumbai travels at a speed of, so here the speed of the train is given as 115 km per hour. Then within 4 hours how much distance is covered by the train. That thing we have to find. Okay, so you know the equation, speed distance equal to what? Speed into time. Okay, that we have to write first. Distance equal to speed into time. Then speed is given. What is actually speed? Speed of the train is equal to 115 km per hour. Okay, speed of the train equal to 115 km per hour. And time. Time is what? Time is 4 hours. Time is actually 4 hours. So how we can calculate the distance? Distance equal to speed into time. Speed is 115 km per hour into what is time actually? 4 hour. Okay, 4 hour. So we can cancel this hour and hour. Then 115 into 4. Actually 115 into 4 is actually 460 kilometer. Okay, distance is in kilometer here. Okay, so distance within 4 hours the train covered a distance of 460 kilometer. The distance travelled by the train starting from Ahmedabad is actually how much distance travelled? For 4 hours it travels a distance of 460 kilometer. Listen, so here the speed is known, then we can calculate the distance. If the speed of an object is given, then we can calculate the distance as distance equal to speed into time. How we can calculate the distance if the speed is given? Distance equal to speed into time. Listen it, distance equal to speed into time. Here the Rajdhani Express train between Ahmedabad and Mumbai travels a speed of 115 km per hour. So the speed is given as 115 km per hour. And we have to find the distance. Will it cover in 4 hours? So time is given as 4 hours. So distance equal to speed into time. So we can write distance equal to speed is 115 km per hour. Then the time is 4 hours. Then hour cancel. Then 115 into 4 is actually 460 kilometer. Okay, all of you got it? Next we can calculate the time taken to cover a particular distance if the distance and the speed is given. Listen it. First we have calculate the speed of an object where distance is actually given. Secondly, we have calculate the distance travelled by the object where the speed is given. Next we can calculate the time taken by the object to cover a particular distance. Their speed and distance is given. Okay, and let us try to understand this by considering another one numerical. Listen it, we can do another numerical based on this. Actually the question is, if a space shuttle is travelling at a distance of 12,000 km per minute, 12,000 km per minute, then how much time will it take to travel a distance of 400 meter? Okay, 400 kilometer. Here a space shuttle is travelling at a speed of, so the speed of space shuttle is given 12,000 km per minute. Then how much time will it take to travel a distance of 400 kilometer? Listen it. We have to calculate the time taken by the space shuttle to travel a distance of 400 kilometer. Isn't it? First we can write the equation. You know the equation? Speed equal to what? Distance by time. Speed equal to distance by time. Here we have to find the time. Okay, how we can calculate the time? Here the distance is, we can write the distance as such. Distance divided by, this time goes up. So in that place the speed will come. So the time is equal to distance by speed. Time is equal to what? Distance by speed. Listen it. This is the equation that we are using here. We know the relation speed equal to distance by time. Here we have to find time. So time can be written as distance divided by speed. Listen it. Time can be written as distance divided by speed. Listen it. Here actually the speed and distance is given. Okay. Actually the speed is, what is the speed actually? Speed equal to 12,000 kilometer per minute. 12,000 kilometer per minute. You know, 1 minute contains how much second actually? 1 minute contains how much seconds? You know, 60 seconds. 1 minute contains 60 seconds. 1 minute contains 60 seconds. So this can be written as 12,000. Okay, 12,000 kilometer per 60 seconds. Okay, 12,000 kilometer per 60,000. That is actually the speed. Then the distance is actually, what is distance? 400 kilometer. Distance what? Distance is equal to 400 kilometer. Listen it. Then we can calculate the time. Time equal to what? Distance by speed. So we can write 400 kilometer divided by, what is speed actually? 12,000 kilometer. 12,000 kilometer per 60 seconds. 12,000 kilometer per 60 seconds. Okay, so we have to divide. Instead of dividing this two, we can actually take the reciprocal of this. Here we have actually what? 12,000 divided by 60. 12,000 divided by 60. What is its reciprocal? 12,000 divided by 60. What is its reciprocal? Actually it is 60 divided by 12,000. This is the reciprocal. So this equation can be written as 400 kilometer. Instead of dividing this, we can take the reciprocal and multiply. Okay, we can take the reciprocal and multiply. So into 60 second divided by 12,000 kilometer. 60 second divided by 12,000 kilometer. Listen it. By simplifying this, actually we will get 2 seconds. Okay, so the time taken by the space shuttle to travel a distance of 400 kilometers is only 2 seconds. Okay, by simplifying this, actually we will get what? 2 seconds. This 0 cancels. Then here 6 2 times. Then again 2 4. Here 2 seconds. Isn't it? This is the numerical actually. Here, if a space shuttle is traveling at a speed of 12,000 kilometer per hour. So the speed of space shuttle is given as 12,000 kilometer per minute. Then we have to find the time taken by the space shuttle to cover a distance of 400 kilometer. So the distance is given as 400 kilometer. The distance is given as 400 kilometer. You know, we have to find the time. We know the relation speed equal to distance by time. Then what is time actually? Time is equal to distance divided by speed. Isn't it? Time is equal to distance by speed. Okay. And here we make a conversion. 12,000 kilometer per minute. You know, 1 minute is actually 60 seconds. So instead of 1 minute, we can write here 60 seconds. Listen it. Then time is equal to distance by speed. That is 400 kilometer by this one, 12,000 kilometer per 60 seconds. Then we separately take 12,000 by 60. Okay. Then take the reciprocal. Then 60 by 12,000. Then instead dividing this, we can take the reciprocal of 12,000 by 60 and multiply with the 400. So 400 kilometer into 60 seconds divided by 12,000 kilometer. By simplifying this, we will get what? 2 seconds. So the space shuttle takes 2 seconds to cover a distance of 400 kilometer. All of you got it? Here actually, first problem, first numerical we have calculated the speed. Then the second numerical we have calculated the distance. And in the third numerical we have calculated the time taken. Okay, actually these numericals are in your textbook. Actually lies page number 197 and 198. Okay, we should copy that 3 numericals in your notebook. Listen it. So we can have the 3 equations. You should study well these 3 equations. What is speed? Speed equal to distance by time. Speed equal to distance by time. Then what is distance actually? Distance equal to speed into time. Okay. Then what is time actually? Time is equal to distance by speed. Okay. These are very, very important relations. You have to write it in your notebook. Okay. Speed equal to distance by time. Speed equal to distance by time. Then distance equal to speed into time. Then time equal to distance by speed. Listen it. Speed equal to distance by time. Then distance equal to speed into time. Then time equal to distance by speed. Okay. Motion can be represented on a graph paper actually. We can represent the motion of an object on a graph. Listen it. That is, in order to represent the motion of an object, actually what is graph actually? It is a pictorial representation. Okay. Actually it is a pictorial representation that shows the relationship between 2 variables. Graph is a diagram or the pictorial representation of the relationship between 2 variables. Okay. Okay. What is graph? Actually, it is a diagram or a pictorial representation of relationship between 2 variables. Okay. You know how you can to draw a graph actually. In order to draw a graph, we need 2 axes. I think you know. Okay. In order to draw a graph, actually we need 2 axes. One is the horizontal axis, which is called the x-axis. Okay. Another is the vertical axis, which is known as what? Y-axis. Okay. In order to draw a graph, we need 2 axes. One is the horizontal axis, which is called the x-axis, and another is the vertical axis, which is called the y-axis. And this x-axis and the y-axis that meet at a point. Okay, this is called origin. This point is called what? Origin. Okay, the x-axis and the y-axis that meet at a point. That point is called origin. And these 2 axes are actually perpendicular. This angle between them is 90. These 2 axes are perpendicular to each other. Listen to it. Here, actually distance time graph. Here the 2 variables are actually distance and time. Okay, so we can relate these 2 variables with the help of a graph. Listen to it. So we can study the variation of one variable with respect to another. Okay, we can study the variation of or the change of one variable with another variable. Okay, actually what is a graph? Actually it is a diagram that shows the relationship between 2 variables. In order to draw a graph, actually we need 2 axes. One is the horizontal axis, that is called the x-axis, and another is the vertical axis, that is called the y-axis. These 2 axes, that is the x-axis and the y-axis, that meet at a point, that is called the origin. Okay. Next we can learn how the motion of an object can be plotted on a graph. How the motion of an object can be plotted on a graph. This thing can be understood by considering an example. Here Arun walked from his house home to school. Okay, he noted the data of his trip as given here. Listen it. Arun walked from his home to school. He noted the data of his trip as given here. That is, in 2 minutes he covered a distance of 100 meter. Then 4 hours it is actually 200. Then 4 minutes he covers a distance of 200 meter. Then 6 minutes it is 300. Here 8 minutes 400. Then 10 minutes 500. Then 12 minutes 600. Then 14 minutes 700. Listen it. This is actually the data prepared by Arun. Then for draw the motion of him by a graph, we should remember certain things. The first thing actually is we have to choose the axis for the two variables. Here the variables are the distance and the time. So first we have to choose the variable, which variable can be drawn on which axis, and another variable on another axis. Here actually the time that is noted on the x-axis. The time is noted on the x-axis and the distance is noted on the y-axis. The time is noted on the x-axis and the distance is noted on the y-axis. Okay, that is about the axis. We have to choose corresponding variables. Listen, the time is represented along the x-axis and the distance is represented along the y-axis. First, that thing we have to decide the which variable will along which axis. That thing we have to decide. Okay, the second is actually the scale. We have to choose. You know, in the graph paper, small squares are there. Here, each square is taken as 1 centimeter. Here, each square is taken as what? 1 centimeter. So, we can write x-axis. In x-axis, actually, time is represented. So, x-axis, the time is equal to actually 1 centimeter. That is equal to 2 minutes. Actually, here, each time interval differs by 2 minutes. Here it is 2, 4, 6, 8, 10 like that. So the difference is actually 2 minutes. So each square having length 1 centimeter, that represents actually 2 minutes. So we can write x-axis time is equal to 1 centimeter, that represents 2 minutes. Similarly on the y-axis actually that represents distance. Then each 1 centimeter that corresponds to 100. Here each differs what by 100 distance. So y-axis distance 1 centimeter equal to 100 meter. Listen it. That is the second step. And the third step, we have to plot the points. We have to plot the points. You know, during the 0 time. Okay, when 0 minute, actually the distance is actually 0 itself. So that here the point is actually 0, 0. We can represent the 0 origin as 0, 0. Okay, the next actually 2 minutes. You know, before that we have to, before plot the points, we have to mark this time and distance in a table. Okay, that is the time 2 seconds corresponds to 100 meter. Again, 4 minutes correspond to 200 meter. Like that we have to make a table. Okay, then corresponds to second 2 minutes. In 2 minutes, Arun covers a distance of 100 meter. So corresponding to 2 minutes, we have to represent 100 meter. Then how we can draw, how we can represent the point. For that, we have to draw a parallel line parallel to the y-axis from 100. So we can draw like this. Actually, this is the parallel line to the x-axis. Okay. Also, we have to draw from 2. We have to draw another parallel line parallel to the y-axis. And these two lines meet here. Okay, actually this point corresponds to what? Actually this point corresponds to 200. Okay, like this you have to write it 2, 100 in bracket. That points correspond to 2, 100. The next point is actually 2 or 4, 200. Okay, here also we have to draw a parallel line parallel to the parallel to y-axis to base 4. Then draw another line parallel to x-axis to base 200. So we got here. These two parallel lines meet here. That point is actually about 4, 200. Okay, so here you have to write 4, 200. The next point is actually about 6, 300. 6, 300. Then corresponding to 6, we have to draw a parallel line like this. Then actually it is 300. Sorry, 300 like this. Then another line parallel to the x-axis to base 300 like this. Okay, so here we got the point as 6, 300. This point you have to write 6, 300. Okay, in all up to where 14, 700 up to where we have to represent the points. Okay, next 8. 8, 400 here actually. Then 10 corresponds to 500 here actually. Then 12, 600 here actually. Then 14, 700 here the point. Then the next circuit we have to join all these lines. Okay, we have to join all these lines. So we got a straight line here. Okay, this is the way to draw a graph that represents the motion of an object. Listen it. The first step is actually we have to decide which variable we have to represent to which axis. Here the time is represented along the x-axis and the distance is represented along the y-axis. Next we have to choose a scale. Here each square on the graph that corresponds to 1 centimeter. So we can write x-axis time is equal to 1 centimeter is equal to 2 minutes. Okay, here then y-axis actually it is distance that corresponds to 1 centimeter equal to 100 meter. Then we have to plot points like this. Then after that we have to join all these points. In this way we can represent the motion of an object using a graph. Actually the distance time graph that provide more information than the table. Okay, from the distance time graph we'll get more information than the table. Then what are the informations that is provided by the distance time graph? Suppose if the distance time graph is a straight line, that indicates that the motion is uniform. Listen to it. If the distance time graph is a straight line, that motion is actually uniform motion. Okay, if the distance time graph is not straight line, the motion is a non-uniform motion. If the distance time graph is not straight line, actually that indicates the motion is non-uniform. Then we can calculate the distance travelled at any instant of time using the graph. Corresponding each time, we can calculate the distance travelled. Listen it. Also, we can corresponding to each distance, we can note at the time also. Listen it. These are the important informations that is provided by the distance time graph. The first is, if the distance time graph is a straight line, then it indicates the object's motion is uniform. Suppose if the distance time graph is not a straight line, that indicates that non-uniform motion. And the distance time graph, from the distance time graph, we can calculate the distance travelled at any instant of time. Also, we can note the time for the corresponding distance. Listen it. That is actually about the distance time graph. Okay, today's class actually we have learned about how we can calculate the speed of an object. Okay, calculating speed, and also we have learned the distance time graph and the important informations that provided by the distance time graph. Okay, children, we have that is the end of today's class. Also we have finished the lesson. Okay, thank you children.